Hello everyone, my name is Shivhari Tewari and today we will learn about statistical inferences. See, it is the important chapter of statistical hypothesis which is highly applicable in machine learning. So let's move further to our topic. So before moving to our first topic, we should know about the learning objectives of this chapter. So in this chapter, we will learn about what is inference, where we will learn the definition of inference, where we use inferences, what kind of inferences we use, and we can say what is the application of inference. After that, we will learn difference between training and inference, where we will see how training is differentiated with the inference. Is inference or training are the same thing, or how inference use training data set. After that, we will move to a further topic, which is inference versus prediction, where we will see is inference or prediction are the same things or they are inherently different, and we will see how prediction and inference are two different domains of the same portion of the same machine learning. Then we will see what is the definition of a statistical inference, what we will do in statistical inferences, how statistical hypothesis is used in statistical inference, and what is the meaning of sampling in statistical inference. After that, we will move further to types of statistical inferences, where we will see how many types of statistical inferences are used in day-to-day life in our we can say hypothesis testing. Then we will see types of estimation, what kind of estimations we are using, and how each estimation is different from others. Then we will see types of errors, that is standard error, the definition of a standard error, and what type of standard errors occurs in this we can say statistical inference. Is it mean square error, or we can say standard deviation error, and many other types of errors we will see. And after that, we will go to our practical relevance, that means where we use practically this statistical inference, and what is the application of this chapter in our day-to-day life. So let's move to our first topic. So what is inference basically? See, in general, inference means a conclusion reached on the basis of evidence and reasonings. That means we have collected some data, we have done several tests on that data, and then we have created a conclusion that this thing happens if the data has gone through these kind of tested. This type of process is called inference. That means some conclusion that we have created using reasoning, testing, and on the basis of evidence. That means the result of the test that we have got, and on the basis of that result we will say that this kind of inference occurs. So what is the inference basically? Inference is the stage in which a trained model is used to infer or predict the testing samples, and comprises of similar forward pass as a training to predict the values. Unlike training, it doesn't include a backward pass to compute the error and update weights. So basically, in the inference we use training dataset, training model, to predict something, to infer something on the basis of our test samples, which comprises some forward passes, and we do not include the backward pass, and that means the back propagation process is not happening in this inference system. See, back propagation is the process where we can say if there are, we can say, 2 or 3 networks connected each other, and they are not, and if they are not giving the same output, then we can do the back propagation. That means we can go backward to our root data, or we can say our first data that we have collected, and test what kind of error has happened if and output due to which output is not coming. So this thing is known as backpropagation. See, backpropagation does not happen in the inference system. That means only forward propagation, only forward passes, only forward pass go in the inference system. That means we will only see the forward results and we will not do backpropagation, and we use the test sample data, or we can say trained model data, training data set, to infer something or to predict something, and we use the testing samples basically. So testing samples are basically the samples that we have collected, and on the basis of that test samples we infer something using that training data model. So this is the definition of inference. Now let's move further. Now, what is the difference between training and inference? See, training refers to the process of creating a machine learning algorithm. That means in training, basically we are creating a machine learning algorithm which involves a use of deep learning framework and a training data set. So training means creating an algorithm to for future use, that we are going to use in future for our inference system. See, this is the difference between training and inference. Basically, the basic difference between training and inference is that in training we are creating a machine learning algorithm, or a training data set, and then that training data set we will going to use that training data set in our future aspects. That means we will going to use that training data sets in our other inference systems. So training refers to the process of creating a machine learning algorithm. It involves the use of deep learning framework. That here is an example of deep learning framework, that is TensorFlow, and training data set. And IoT data provides a source. IoT data set provides a source of training data, and that data scientist and engineer can use to train machine learning models for a variety of use cases. That means we are creating an algorithm for our inference system using some deep learning framework and IoT. Using the IoT, we take the data sources. The IoT is basically provides the data source that is used by the scientists or data engineers to train our machine learning model for various use cases. And from some examples are like failure detection system or consumer intelligence. See, this is the definition of training. That means in training we are creating a framework, a algorithm using deep learning we can say tactics, deep learning frameworks, and then we take some training data set, and that training data set is added to our framework, and then we test that training data set using that framework to test whether our data set is used for our future cases like failure detection system, expert systems, customer intelligence, and deep fake algorithms. So these all comes under the training. In training, basically we are creating algorithm. And now let's move to inference. Now what is inference basically, and how inference is different from training? So inference refers to the process of using a trained machine learning algorithm. That means here we are using a already created machine learning algorithm to make a prediction. Now this is the basic difference between training and inference. In training we were creating an algorithm, and in that algorithm we were adding some data sets. That data set was provided by IoT, and the data scientists and data engineers use that data set to train machine learning models. So this is the kind of, we can say, flow chart in training. First we will involve some deep learning framework. Then we will take some training data set. Then that training data set is provided by the source by the IoT sources, where we will find the source of the training data, and on the basis of that source, the data scientists and the data engineers use that training data to train machine learning models that we are going to launch. See, this is the definition of training. Now, what is inference? Inference refers to the process of using a trained machine learning algorithm. That means we are using that trained machine learning algorithm in inference to predict something, to forecast something, to estimate some result. Here IoT data is used as input to a trained machine learning model. Here IoT data was a training. Here the data which was provided by IoT, it was in training, was basically a training data set. In inference, the data which was provided by IoT is basically a input data set. See, there is a big difference between input data set and training data set. Training data set is used to train our machine learning model and for further test. In input data set, we will giving input to predict something, to estimate something. This is the basic difference between a training data set and an input data set. So in inference, we are giving an input data set from IoT to a trained machine learning model. Now it enabling the predictions that can guide decision logic on the device at the edge gateway or elsewhere in the IoT systems. See, inference is basically used in IoT systems. It is the major part of IoT system. Now, how we are using training data set in inference? See, in training we have created a machine learning algorithm, and this is how this flow works. We have created a trained machine learning algorithm. Then we use that trained machine learning algorithm in inference system to predict something, where IoT data is used as an input data set to machine learning model. Then that model enables the predictions that guide us to our decision logic, and at the edge gateway or elsewhere where we are going in IoT systems, that means what we are going to decide on the basis of that training data set which we have given the inference system as an input. See, this is the difference between training and inference system. In training, we are creating machine learning algorithm. We are creating some algorithm. We are using data set to train our machine learning model and to use in IoT systems like failure detection, customer intelligence, consumer intelligence. In inference, we are basically use that training model. That means that machine learning algorithm is used in inference system, and IoT data is used as an input data model. That means input data is given to a machine learning model to enable the prediction, and on the basis of that prediction we decide what will be the result in our future. Let's move further. See, here's the difference between input IoT data input to ML models. That means training versus inference. See, you can see in training, learning a new capability from existing data. That means there is a data set which is already available. There is a deep learning framework like TensorFlow. I have written this as TF. Then here is a training data set, and that training data set is given to we can say machine learning model. This is the model, and this model is going to store it as a, we can say, pattern, or we can say a logical data warehouse. And if there is a, we can say, camera in front of computer, and if the pattern which is given to a camera is matched with the training data set, in that case it will say that the animal which is standing in front of the camera is cat, otherwise it will say it is dog or something. So this is how training of machine learning model works. Now, what is the inference? This is the training model which we have created in training, and this training model is used as it is in inference system. That means you can see here is a camera. It is a new dataset given by IoT. Which is, we can say, app or service featuring capability. Then the training dataset is given to machine learning model, and machine learning model is going to check whether this pattern is matched with this pattern. If this pattern is matched with this pattern, that means that an animal standing in front of the camera is cat. If this pattern does not going to match is this pattern with this installed pattern, we can say installed training dataset, in that case it will not going to give you a correct result. So this is how training is differentiated with inference. I hope you understand the basic difference between training and inference until now. Let's move further. Now, what is inference versus prediction? Here we will learn basically what is the difference between inference and prediction. Now, what is inference? As we have studied earlier, we have saw earlier that inference is using the trained dataset model, and that model, if that model is as it is used in, we can say, inference system, and if the inference is, if the pattern is matched with that training data model, then only in that case it will give the correct result, that is cat. Now, how we can compare it with the prediction? See, inference use the model to learn about the data generation process. So in inference, we are not going to care about what will happen in future. We are not going to forecast something. The inference is use the model to learn about the data generation process. That means how the data will be generated in inference system. It is all the inference system care about. This is the major part of inference system, that is, we use the model to learn about the data generation process. In inference, we do not predict anything. We are not going to forecast something which is going to happen in the future. Okay, it is not like something we are going to forecast using our previous data set. In inference, we will only care about data generation, that is how the data is generated and how the training model is used in that inference system. Let's go to an example. Like, you want to understand how ozone levels are influenced by temperature, solar radiation and wind. Now you assume that the residuals are normally distributed and you use a linear regression model in order to harness the information from the full data set, and you do not care about predictive accuracy. Now you fit the model on that data set. On the basis of the fitted model, you interpret the role of the features on the measured ozone level, for example, by considering the confidence bands of the estimates. Now see, here you have taken some data like temperature, how ozone level is influenced by temperature, solar radiation and wind. Now you assume that the residuals are normally distributed. That means their distribution is normal, and you have used a linear regression model. Look, there are two types of regression: linear regression and logistic regressions. Now, in order to harness the information from full data set, that means if you want to store the full knowledge from the full information from the data set, you have taken all the data from the collected data set without caring about the predictive accuracy. That means you do not care that our prediction will be true or not. That means it will not care about the future accuracy, that this thing will happen or not. It will be only a part of coincidence if that thing happens, and it will be very okay if that thing not happens. So it basically harnesses the information from the full data set, and it does not care about the predictive accuracy. See, this is the very big term, predictive accuracy. That means the accuracy which is going to use uh, which we are using to forecast our result. So the predictive accuracy is not a concern for inference system. We basically care about data generation process, and to see that we will take the full data from our data set, and then we fit that model to our inference system, and on the basis of that model we interpret the role of features on the measured ozone level. That means we only interpret the result that this thing is happening to ozone level, and these are the consequences of ozone levels till now. And in that case we will not going to forecast something about what will going to happen in the future. So this is how inference works in we can say ozone level model, where we have created the data, the full data set, and then we fit that model, we fit the full data set on the model, and on the basis of the fitted model we interpret we interpret the features of the measured ozone level. That means what are the features of measured ozone level and what is happening in ozone right now. This is what is going in inference. Basically inference is all about data generation process, not about forecasting. Let's move further. Now what is prediction? Look, in inference I've told you about data generation process. This was the major concern about inference. Now in prediction we use the exact model that we have using in inference system. Here we have used the model to learn about the data generation process. In prediction we are using the same model to predict the outcomes for the new data points. That means on the basis of our old result we are going to predict that what will happen in the future and what will be the outcome in the future. Let's take the same example, like we want to understand how ozone levels are influenced by temperature, solar radiation and wind. Now we assume that the residuals are normally distributed and we are using linear regression model. So in order to harness the information from the full data set, we do not care about predictive accuracy. See, in prediction 2 we will not care about predictive accuracy. That means it will happen or not, it depends on our data. We will not care about that. It is not our concern to predictive accuracy, to see the accuracy. We fit the model on the full data set, the model that we have created, the machine learning model basically, and on the basis of that fitted model we interpret the role of the features on the measured ozone level, and on the basis of that features we predict the outcomes for the new data points, what will happen to the future if we are including some other data in our we can say previously installed data set that we have fitted in the model. So this is what is the difference between inference and prediction. See, in inference we care about the data generation process, we do not care about predictive accuracy, and we learn about what is going on with our current situation. Like in ozone we only care about the role of features on the measured ozone level. In prediction we are using the same model to predict the outcomes for the new data points, and like we have taken the same example, ozone levels, and same data set that is used in the previous example. We have used the same data set, and without caring about predictive accuracy we fitted the model on the full data set, and on the basis of that model we interpret the role of the features and predict the new outcomes, that if we added some new data points and then we have tested that data set on that model, then what will be the result. So this is what happens in inference and prediction. See, these two look like same, but this is how they are different. They both are different from each other. See, here is the flowchart of machine learning and statistics, and how inference and prediction both are used in machine learning and statistics. See, prediction is the major part in machine learning, which is used by inference to learn about data generation process. Machine learning is not about prediction. Machine learning is all about data generation. That means we have used the previous data set, the previous predictions, and then we will studied about how that data affects the inference system. Now, in statistics, we use the inference model to predict our new outcomes. So this is how inference and predictions are different from each other. Now, what is inference? Statistical inference. Look, statistical inference makes proposition about a population using data drawn from the population with some form of sampling. Now, in our other video, which is about statistical hypothesis, we have learned about sampling. Sampling means collecting some sample data, and then we are going to test that sample data, and then we calculate the test statistics, and then we will go for the decision level. So in a layman's language, the collection of sample data is known as sampling. So statistical inference makes propositions about a population. That means the population we have the population parameter that we have collected, and the data which we have drawn from that particular population. Like in the statistical hypothesis, the video of statistical hypothesis, we have discussed about hospital administrator, that how hospital administrator predicts that average stay of the patient in the hospital is not more than 5 days, which means he has collected the data of all the patients. Then he filtered that data and removed the data of those patients who were seriously injured or who were admitted in the ICU or suffering from some serious disease. Then he will take the data of normal patients who has admitted to the hospital. Now, if the average stay of the patients whose data he has collected, the administrator has collected, is 5 days or less than 5 days, in that case he can say that the patient stays in the hospital not more than 5 days. So this is how the population parameter works, and this is what sampling looks like, and this is the importance of sampling basically. Now, given a hypothesis about a population for which we wish to draw inferences. Now, statistical inference consists of first selecting a statistical model of the process that generates the data, second deducing proposition from the model. See, basically statistical inference is about making a proposition. That means it proposes a theory about a population. So here it is about we can say predicting something, or we can say giving a hypothesis about some population and the data which is drawn from the population. So a hypothesis about the population for which we wish to draw inferences, it consists of two basic things. One thing is selecting a statistical model. What kind of a statistical model is used in the process of data generation? Because we have learned previously that inference is all about data generation. And second thing, what will be the proposition from that data model that we are going to use. So this is what statistical inference is defined. Statistical inference is making proposition about a population. That means a proposition which is deduced from the population from that population from which we have drawn a data which in the form of sampling, and that data is used for some we can say for some hypothesis, and then we have drawn some inferences about that particular data, and after that we have deduced some proposition using a statistical model which is used to process the data, which is used for the process of data generation. So this is how statistical inference works. Now there were two scientists, Konishi and Kitagawa, which stated that majority of the problems in statistical inference can be considered to be problems related to statistical modeling. That means statistical inference is highly dependent on statistical modeling, and statistical modeling means using statistical model for the process of data generation. So this is that means they are saying that statistical inference is dependent on statistical modeling, and the majority of the problem in the statistical inference are the problems of a statistical modeling. That means what kind of statistical model we are going to use in statistical inference. Now what is sampling? We have discussed earlier the basics of sampling. So sampling, what is the definition, basic definition of sampling? Look, I have told you about example of hospital administrator where he has collected the data of patients, and then he has filtered the data, and he has collected the data of only those patients who are not seriously injured or we can say suffering from some serious disease, or who are not in ICU, and then he will calculate the average stay of those patients, and if the average stay of those patients is not more than 5 days, only in that case he will predict something, that the patients are staying in the hospital is not more, the stay of patients in the hospital is not more than 5 days. So where sampling is used, basically sampling is used in selecting the data of all the patients, and then filtering the data and collecting the sample of those patients who are not suffering from any serious disease, or who are not seriously injured, or not in ICU. So sampling is a term used in statistics. It is the process of choosing a representative sample from a target population. Now, what is the target population? The target population, like I said earlier, the target population is the whole data which the hospital administrator has been collected to predict something, to give the hypothesis about something. Now this is the patients, the data of all the patients in the hospital. Here it is the hospital administrator. Now how he will take the sample from that target population? Look, the data which he has collected is the target population. Here all the patients are staying in the hospital, so it is the target population. Now what will be the sample? The sample is those patients who are not seriously injured, or who are not suffering from any serious disease, or who are not in ICU, which is represented as P dash. That means this is the sample which the administrator has collected from the target population, that is the target patients, and collecting data from that sample in order to understand something about the population as a whole. That means to understand whether these patients are not seriously injured or seriously ill, or they are not suffering from any serious disease, or they are not in ICU. So this is the data of those patients who are just kind of we can say average injured, or we can say suffering from any average disease, and they need to stay in the hospital for some regular surveillance. So only this kind of data is used for the hospital administrator to define the average stay of the patients. Now, from that sample, in order to understand something about the population as a whole, some examples are of sampling. There are some examples like random sampling, clustering, or some types of sampling used in statistics. Look, clustering and classification are basically two types of sampling. Classification, where we classify the type of our data, what kind of data is used, and clustering means creating a cluster of whole population, like it is a cluster of patients. Now, what is the main objective of sampling? The main objective of sampling is to draw conclusion about the unknown population. Look, here patient is the unknown population. We don't know about every patient, but we have to draw a conclusion about patients so that the hospital administrator can go for the better results. Now, for that thing, he will take a sample of patients. So the main objective of sampling is to draw conclusion about the unknown population from the information provided by the sample. Like the information provided by this sample is the average stay of the patients is not more than 5 days. So this is how this information works for the hospital administrator. So the main objective of sampling is to draw conclusion about the unknown population from the information provided by the sample, and this whole process is called statistical inference. That means to draw conclusion using the sample that someone taken for some testing of some hypothesis, and he has drawn some conclusion. He has created a decision, and that conclusion, that prediction that he has taken is called statistical inference. So this is how basically statistical inference is defined. So the conclusion of a statistical inference is known as statistical proposition. That means the proposed conclusion given by the tester, by the data scientist, by the tester, or in our example the hospital administrator, is called as statistical proposition. Now, what are the type of statistical inferences? Look, there are many type of statistical inferences. Like here, the many I have mentioned. Number one is point estimate. Point estimate means a particular value that best approximates some parameter of interest, which means we can say, let's take example of a school, and here the 2/3 of the students of school prefers the Pepsi Cola over other brands. Now suppose that there are 30 students in schools, and the manager of canteen wants to test that how many students of the school prefers Pepsi Cola over other brands. Now how he is going to test? In the canteen, he has we can say stored a crate of Pepsi Cola, and he has stored a crate of some other brand. Now he will see how many students prefer Pepsi Cola over other brand. If the 20 out of 30, that means 2/3 of the school prefers 20 out of 30 students prefer Pepsi Cola, then he will say that 2/3 students of the school prefer Pepsi Cola over other brands. So that 2/3 is basically a particular value that best approximates some parameter of interest. So this kind of statistical inference is known as point estimate, to estimate the best approximate value of some parameter. Now, what is the interval estimate? The interval estimate, or we can say, for example, we can say a confidence interval, an interval constructed using a data set drawn from a population, so that under repeated sampling of such databases, such intervals would contain a true parameter value with probability at the stated confidence level. Now, interval estimate is basically we can say used for a given interval, like the average, like in our previous video we have discussed about the average income of the family in Philippines is 36,000 PHP. So how the person who is testing that average income is of the families in Philippines is 36,000. He has taken the data and he has gone some random city and he has created an interval that from this family to this family, these are the major of this city, and their average income is 36,000. In that case, he has estimated that the average income of the city in Philippines is 36,000. So this kind of interval estimate is known as interval estimate. This is also a type of statistical inference which basically gives an estimate about an interval constructed using a data set drawn from a population. See, population here is the people of Philippines. That means he has taken the example of a random city in Philippines and he will check that what is the interval of the people whose average income is 36,000. Now in that case, if the average income of families in a particular interval is, we can say, 36,000, only in that case he will say that in this city the major of the city earns 36,000 PHP. So this is how interval estimate works. So that under repeated sampling of such data sets, such intervals could contain a true parameter value with probability at the stated confidence level. That means there is a confidence level given from the particular data set, and this confidence level is also known as the confidence interval. After that, there is a credible interval. Now what is credible interval? The credible interval is a set of values containing, for example, 95% of posterior belief. Posterior means we can say previously happened events. So the credible interval basically gives the result on the basis of previously happened 95% of previously happened events, and that means it is 95% confident about the upcoming results, which is based on the previously happened events. Now here 0.05% chances of rejection of this hypothesis. That 0.05% is known as significance level, as we have discussed in our other video. So that means the credible interval is a set of values containing 95% of posterior beliefs, and it is basically used in rejection of hypothesis. That means the credible interval we are using the credible interval to reject our hypothesis, and that means we have created a belief, or we can say we have estimated a result without testing our data set. After that, another type of statistical inference is known as clustering or classification of data points into groups. So these are the types of statistical inferences. Now, what is parameter estimation? The parameter estimation is concerned with the obtaining numerical values of the parameter from a sample. Now, how we are going to obtain a numerical value from the parameter. So parameter estimation is basically about giving we can say numerical values like 2 by 3. In our previous example we have seen 2/3, or we can say average income of the cities of the city in Philippines is 36,000. So this is the, we can say, numerical values which is given by a parameter estimation. So probability theory tells us what to expect when we carry out some experiment with random outcomes in terms of the parameters of the problems. That means here we are going to apply some probability theory to tell us what to expect. That means we cannot expect some random result with our experiment. We should have to go as in a mathematical way to check what should we expect when we carry out some experiment with random outcomes. That means if we are doing some experiment with some random data sets which will going to give us some random outcomes, in that case probability theory tells us that what we should expect in terms of parameters of the population of the problems of the problem statement. This is how probability theory is used basically in parameter estimation. So basically here we speak of making statistical inferences about the parameters. The parameters, look, if we are talking about inference, we are talking about prediction. If we are talking about testing of hypothesis, we have to take some parameters. Either it is population parameter, or it can be a data drawn from some sample. It can be anything, but it should be kind of parameter on which we are going to test our hypothesis, on which we are going to test our inference, that it will going to generate some data, or if it is going to predict something or not. For example, a company may be interested in estimating here, like I have said, estimation. The major part of inference is estimation. In estimating the share of the population who are aware of its product. Now company is producing some product, and he has taken some random outputs from we can say its sales manager. Now the company is interested in estimating that how much share of the population is given to the customer, and what will be the output of our sales. Now in that case, company will use probability theory to check whether our random outcomes in terms of parameters of the problem will be correct or not, and what should we expect from our sales, and what will be the output from our random data sets. So this is how parameter estimation works in statistical inference. Now what is hypothesis testing? The hypothesis testing is concerned with the passing a judgment on some assumption which we make on the basis of some theory or information. So testing of hypothesis means we are testing our hypothesis on the basis of some assumption that we have made. Then we have tested our data set using statistical inferences about a true value of a population parameter. So here hypothesis testing is used in statistical inferences, and this is the role of hypothesis testing in the statistical inference. The hypothesis testing is basically that either our assumption that we have made is going to be true or not about the true value of the population parameter, or we can say on the basis of some theory or information that we have given. Now what is statistical hypothesis tells us about our statistical inference. A statistical hypothesis, sometimes which is also known as confirmatory data analysis, is a hypothesis that is testable on the basis of observing a process that is modeled via a set of random variables. A statistical hypothesis test is a method of a statistical inference. Look, statistical hypothesis basically concerns with that our theory is going to be true, or it cannot be going to be true. It is taking both of the case. I have discussed in our other video that there are two types of statistical hypothesis, that is null hypothesis and alternative hypothesis. The null hypothesis means an initial assumption, that is something which is going to happen in every case, and our alternative hypothesis is saying that something which will not going to happen, either it will going to less than this or greater than this, then the null hypothesis condition. So it is basically a method of statistical inference to test whether our statistical inference is going to be true or not on the basis of given data set. Now, what is the comparison between estimation and hypothesis testing? Look, in estimation, we are using the sample data and we estimate some, we can say we are going to forecast the result on the basis of our previously given data. And we calculate the probability. We are using probability theory to tell us what to decide, what to expect from our given data set, from which we are going to calculate our test statistics. So it is basically utilizes the information of sample. In parameter estimation, we use some formula in which we substitute the observation of a sample in order to obtain numerical estimate of population parameter. That means when we use some formula in which we substitute the observation of a sample, that means we have collected the observation of the sample data, and we are using some formula in parameter estimation to obtain numerical estimate of our we can say population parameter. And in hypothesis testing, basically we do not concern about the numerical estimate. That means either value can be numerical or it cannot be numerical, but there must be a hypothesis which should be true or which cannot be true. Both cases can happen in hypothesis testing. Now in parameter estimation, we use some formula in which we substitute the observation of a sample in order to obtain numerical estimate of the population of the population parameter. In hypothesis testing, we begin with some assumption. That means we have previously made some assumption. We have made some we can say predictions about what will going to happen about the true value of population parameter, and after that we calculate certain test statistics and then draw conclusion. This is the difference between estimation and hypothesis testing. In estimation, we first utilize the information of sample, then we use some formula in which we substitute the observation of a sample in order to obtain numerical estimate of that given population parameter. In hypothesis testing, on the other hand, in a hypothesis testing, we basically assume something first, and then we going to calculate the test statistic collecting. We are going to collect the data. We are going to calculate the statistics. Then we will draw the conclusion using our decision, logic decision. Now, what is point estimation? Basically, an estimate of a population parameter given by a single number is called point estimate of the parameter. So, an estimate of the population parameter given by a single number, which means a single number, a single result can give the estimate of the whole population parameter, is called as point estimation. Like in previously discussed example, the average length of stay of the patient is not more than 5 days. Here 5 is that single number which estimates the whole population parameter, and it is saying that the average length of the stay of patient is either 5 days or less than 5 days, but it will not more than the 5 days. This kind of estimate is known as point estimate of the parameter. Now, point estimate involves the use of sample data to calculate single value, which is known as point estimate, since it identifies a point in some parameter space. That means it involves the use of sample data, like sample data of patients who are not seriously injured or who are not in the ICU. In that case, only the data of those patients is used to calculate a single value, not the data of other patients that we have filtered already. And it is used to serve as a best guess, or we can say best estimate of an unknown unknown parameter. So the parameter is unknown basically. We don't know how many patients are admitted on the daily basis in the hospital. But we have to calculate the average stay of the patient in hospital. So in that case, we are going to collect the data. We filtered that data and create and remove those patients who are seriously injured or who was admitted in the ICU, and then we take the data of those patients and calculate the estimate that the average stay of the patients in the hospital is either 5 days or less than 5 days. So this is how point estimation works, and it involves the point estimate, that is also known as the best guess. I hope you understand my point. Now, more formally, it is the application of a point estimator to the data to obtain a point estimate. Here another example is given, that is, a firm wishes to estimate the amount of time its salesmen spend on each sales call. Now, if a firm wants to estimate amount of the time its salesmen spend on each sales call, like it has said that 70%, 60% of its salesperson spend their time on the sales call. So first he will take the data of all the salesperson. Then if they have given the company's the phone number from the company, then he will we can say collect the data of their calling to the customers, and then they can check whether they have spent their particular time, their office time, in calling the customers or in the other things. That's how they can estimate whether the average amount of time they have used to call their salesperson has used to call the customers or in other things. Let's move to our next topic. Now, what are point estimators? We have already mentioned here the point estimate. Now, what are point estimators basically? There are a variety of point estimators, each with different properties. So basically, the definition of point estimators are the we can say the parameters which is used to serve as a best guess is called the point estimators. It is the application of point estimator to the data to obtain a point estimate. So the point estimators are used to give the best guess, or we can say the best service, or we can say the numerical result to the person who is testing his inference on the given population parameter. Now, what kind of point estimators are used in our point estimation system? There are a variety of point estimators, each with different properties. Number one is minimum variance mean unbiased point estimator, which is used to minimize the risk, or we can say expected loss of the squared error loss function. After that, there is the best linear unbiased estimator, which is we can say same as the minimum variance. The difference is it is going to give us the best one instead of giving the minimum variance. Now there is the median unbiased estimator, which is minimizes the risk of absolute error loss function. Then there is a maximum likelihood estimator, which is going to test whether what is the maximum likelihood of the result on the basis of our given parameters, and on the basis of that he will give the best result. He will give the best estimations of our we can say predictions on the basis of our given population parameters. and then there are method of movements and generalized method of movements. Now, what is interval estimation? An estimate of population parameter given by two numbers between which the parameter may be concerned to lie. The interval estimation consists of lower and upper limits. Look, if we are talking about interval, there are two limits, that means lower limit and upper limits, and then we assign a probability that this interval contains a true value of the parameter. That means the population parameter, which is given by two numbers between which the parameter may be considered to lie, which means there are we can say an interval like 12 to 3 is the estimated time in which many we can say approximately many people who were physically weak dies between 12 to 3. Now here the upper limit is 12 and the lower limit is 3. Or we can say another example like we can say the most of the busy schedule of office lies between 4 p.m. to 6 p.m. So these kind of estimations are known as interval estimations. The interval estimations consist of lower and upper limits, that means 4 is the upper limit and 6 is the lower limit, and we assign the probability which is say 95% confidence, 99% confidence, but with some significance value of 0.01 or 0.05. So this is how the interval estimation works, and this is how interval estimation gives the estimation about a given interval. That means the interval between the two number in which the parameter may be considered to lie, and this is how we define interval estimation. So interval estimation is the use of sample data to calculate an interval of possible values of unknown parameter. This is in the contrast to point estimation, which gives single value. So basically how we use the interval estimation. Look, here is the sample data. If sample data is given, now there is an interval in the sample data, like we can say let's take the example of hospital. So the administrator says that 40 to 60% patients of hospital leave the hospital in 3 days. In that case, he will also filter the data of those patients who don't need to stay in the hospital not more than 3 days. Now in that case, he will filter the data, he will calculate the interval of the possible values of that particular data, and then he will test the statistic and check whether his data is true, or 40 to 60% of the patient of the hospital leave the hospital in 3 days or in less than 3 days. So this is how the interval estimation works. It is basically a contrast to point estimation, which gives a single value. Jerzy Neyman identified interval estimation as distinct from point estimation, or estimation by unique estimate. Now, what are the types of interval estimation? The most prevalent form of interval estimations are: number 1 is confidence interval, number 2 is credible intervals. Now, what is confidence interval? The confidence interval is a type of estimate computed from the statistics of the observed data. That means there is observed data, and it is a type of estimate computed from the statistics of that data. Now this proposes a range of plausible values of unknown parameter. That means it gives a range of plausible values which can be accepted for the unknown parameter. For example, the mean of that parameter. The interval has an associated confidence level that the true parameter is in the proposed range. That means the interval which they have calculated has associated to a confidence level. Because of that confidence level, it is named as the confidence interval, that the true parameter is in the proposed range. Given observations, like there are observations like x1 to xn, this is the observation, and there is a confidence level of gamma, then a valid confidence interval has a gamma probability of containing true underlying parameters. The level of confidence can be chosen by the investigator. That means the investigator can choose that what kind of level of confidence is applied to a particular observation or a particular interval, and on the basis of that he will calculate some values, or he will give some prediction or results. In general terms, a confidence interval for an unknown parameter is based on sampling the distribution of corresponding estimator. So this is how we define the confidence interval. Now, what is credible interval? The credible interval, which is also known as Bayesian statistics, the credible interval is an interval within which an unobserved parameter value falls with a particular probability. That means some unobserved parameter value which we have we can say which we have find right now, and that unobserved particular parameter value falls with some probability in credible interval. It is a kind of interval in which the unobserved parameter values falls. So it is an interval in the domain of posterior probability. That means probability distribution which is based on previously happened events. Then it is the interval domain of that kind of distribution, or we can say predictive distribution. That means prediction of those events prediction of events on the basis of previously happened events, and then calculating the probability of that on the basis of that posterior events. So this kind of interval is known as credible interval. The credible intervals are analogous to confidence interval. That means it will give the analog values, that means numerical values on the we can say in comparison with confidence interval, it gives much more numerical form of values. In frequentist statistics, although they differ on a philosophical basis. Now, what is the frequentist inference? The frequentist inference is a type of statistical inference that draws conclusions from sample data by emphasizing the frequency or proportion of the data. An alternative name is frequentist statistics. That means it is a kind of statistical inference that can draw conclusion from sample data by emphasizing the frequency or proportion of that particular data. So this kind of inference is known as frequentist inference. Now, how we can choose the credible intervals? Credible intervals are not unique on a posterior distribution. The methods for defining a suitable credible interval includes choosing the narrowest interval, that means the smallest interval between two numbers, then which for a unimodal distribution will involve choosing those values of highest probability density, including the mod, the maximum posterior. This is sometimes called the highest posterior density interval, HPDI. Choosing the interval where the probability of being below the interval is as likely as being above it. This interval will include the median. This interval will include the median and sometimes called equal tailed interval. assuming that the mean exists, choosing the interval for which the mean is central point. Now, what is the contrast with confidence interval? A frequentist 95% confidence. A frequentist 95% confidence interval means that with a large number of repeated samples, 95% of such calculated intervals would include a true value of parameter. In frequentist terms, the parameter is fixed and the confidence interval is random. So this is how we can say the frequentist 95% confidence interval 95% confidence interval can be taken. The Bayesian credible intervals can be quite different from frequentist confidence interval for two reasons. The credible intervals incorporate problem-specific contextual information from the prior distribution, whereas confidence intervals are based only on the data. That means we can say the credible interval is basically based could be based on the prior distribution, or we can say posterior events, while confidence interval are only based on the data that we have taken from some we can say samples. The credible intervals and confidence interval treat nuisance parameters in radically different ways. Now, what kind of errors happen in statistical inference? Number one is standard error. The standard deviation of sample statistics is called as standard error. If an estimator is unbiased, either exactly or approximately, its performance is measured by V theta by its standard deviation. So here's the formula of a standard error. Calculating the standard error, that is sigma theta equals to under root of V theta, which is also known as standard error or standard deviation. So the standard error is basically also called as standard deviation, which is used in statistics, and we calculate the standard deviation, that how much the data is deviated from our particular result, or we can say our particular mean or median. Often an estimator's standard error is a function of theta or the other parameters. These must be replaced by estimates before we can actually calculate a value. Now, the standard error of mean when population standard deviation is known. The formula of that standard error is sigma upon under root of n, where n is the data which we have collected from our sample. The standard error of mean when population standard deviation is not known, which is s upon under root of n. Then there is mean square error. In mean square error, we measure how far an estimator theta dash is from the true value theta using the mean squared error. Here is the formula of mean square error, that is theta comma theta dash. Both we can say both estimators are used, and we use MSE theta dash comma theta equals to error of theta dash minus theta ka whole square of theta dash minus theta. We can show that MSE theta dash comma theta equals to bias of a square by the biasing point or square of biasing point plus v theta dash. For an unbiased estimator, that means bias equals to 0, mean squared error equals to v theta. That means the v theta value will be equal to mean square error if the bias value equals to 0. Many biased estimators are approximately unbiased in the sense that MSE is approximately equal to v theta dash. There are some examples of standard errors, like from random sample of 36 New Delhi Civil Services personnel, the mean age and the sample standard deviation were found to be 40 years and 4.5 years respectively. Construct a 95% confidence interval for the mean age of civil servants in New Delhi. From random sample of 36 New Delhi civil personnel, the mean age and sample standard deviation were found to be 40 years and 4.5 years respectively. Then how can we construct the 95% of confidence interval? And there is another example. A manager wants an estimate of average salesman of his company. A random sample of 100 out of 500 salesmen is selected, and average sales is found to be 750,000 rupees. Given population standard deviation is 150,000. Manager specifies a 95% confidence interval. What is the interval estimate for the average sales of the salesman? So these are standard deviation errors and mean square errors which happens if we take a random data without any observation. Now, what are the practical relevance of statistical inferences? So statistical inferences is basically used in predicting some results, like in weather forecasting, in data forecasting. We have discussed about ozone layers, the changes in ozone levels. So these are some examples, like testing how many women suffer from nightmares, then establishing the authorship of documents, evaluating the effect of full moon on the behavior, then testing the claims of handwriting analysts. So these are some kind of practical examples that where we use statistical inference to discuss to test whether our prediction will be true or not. After that, thank you for watching this video. My name is Shivhari Tewari, and I hope you like that video and you understand the point that we have discussed. Thank you so much.